29 Incredible Facts About the Milky Way, your home galaxy. We live inside a galaxy we can't step outside to photograph. Every famous portrait of the Milky Way is either a stitched panorama from within or an artist's rendering based on star counts, dust maps, and radio surveys. That limitation is oddly liberating. It forces us to build our picture from physics. The Milky Way is a barred spiral island of stars, gas, dust, dark matter, and magnetic fields. It is still assembling itself through mergers, it makes new suns while shredding old companions, and it is flying through space with a destination, an eventual encounter with Andromeda. In this episode, you'll tour the Milky Way from core to halo, learning how a galaxy is structured, how it feeds and grows, and why our neighborhood looks the way it does. Each fact below is written so you can illustrate it with generic NASA ESA imagery, publicly available surveys, radio, IR, optical, simple diagrams, or text on screen. No perfect, outside shot required. Let's meet our home properly. The Milky Way is a barred spiral, and the bar matters. The Milky Way isn't a simple pinwheel. At its center sits a stellar bar, a rectangular stream of stars and gas that rotates like a slow propeller. From the bar's ends, the main spiral arms unfurl. The bar acts like a traffic controller. It funnels gas toward the central regions, feeds star formation, and helps set the pattern speed that shapes the whole disk. Easy visuals. Artists' top-down rendering of a barred spiral. Overlay a softly glowing bar with two arms peeling away. Add a caption, not to scale. Illustration. How big is it? Roughly 100,000 to 200,000 light-years across. Textbooks used to quote approximately 100,000 light-years, but outer gas and stars extend farther. The stellar disk comfortably reaches approximately 100,000 light-years. The gas disk and dark matter halo stretch much more. The exact size depends on what you measure: light, gas, or gravity's reach. Easy visuals. Scale bar. Sun at approximately 26,000 light-years from center. Faint outer ring showing extended gas. How many stars? Hundreds of billions, with caveats. Counts depend on how faint a star you include. A handy rule of thumb is 100 to 400 billion stars. But galaxies aren't just stars. Add in planets, brown dwarfs, stellar remnants, cold gas, and a massive dark halo, and the Milky Way's stuff becomes far more interesting than a simple star count. Easy visuals. Crowd of star dots fading into dust lanes. Text on screen. Hundreds of billions. Estimate. There's a supermassive black hole at the center. At Sagittarius A** lurks a black hole about 4 million solar masses. We cannot see it directly in visible light, dust blocks our view, but infrared observations track stars whipping around it in tight orbits, and radio arrays resolve its compact shadow. It sleeps most of the time, but it's the dynamical anchor of the bulge. Easy visuals. Artist's impression. Dense star field. A faint glowing accretion ring at center. Disclaimer, illustration. The Sun orbits the center in approximately 225 to 250 million years. One lap around the galaxy is a galactic year. The Sun has made roughly 20 to 25 laps since it formed. As it orbits, the Sun also bobs above and below the galactic plane and drifts through different interstellar neighborhoods, dense clouds, diffuse cavities, and everything in between. Easy visuals. Top-down galaxy sketch with a glowing dot tracing a circular, oval path. 1 galactic year approximately equals 230 mir. We live in the Orion Cygnus spur, not a major arm. The Milky Way's biggest arms are named Scutum, Centaurus, and Perseus. The Sun sits between them in a smaller spur or local armlet. That's why the Milky Way band looks brightest toward Sagittarius. We're looking inward along rich star fields, and dimmer toward the anticenter. Easy visuals. Stylized arm map. Major arms thick and bright. Our spur thinner, with a "you are here" dot. The disk comes in two flavors, thin and thick. The thin disk contains most of the gas, dust, and young stars. It's where ongoing star formation lives. The thick disk is puffier, older, and more metal poor, with stars that have more tilted, heated orbits. The thick disk likely formed early, perhaps through mergers that heated the young galaxy. Easy visuals. Edge on schematic. A slim bright lane. Thin disk, within a broader faint layer, thick disk. Surrounding everything is a vast, faint stellar halo. Beyond the disk and bulge lies a ghostly population of ancient stars, globular clusters, and shredded debris from long-ago mergers. The halo is a library of the Milky Way's archaeology. Its star streams trace the orbits of cannibalized dwarf galaxies. Easy visuals: wide field with thin, curving star streams wrapping around an edge-on disk. The Milky Way's dark matter halo dominates the mass. Visible matter, stars and gas, is only a fraction of the galaxy's total mass. The rotation curve, how orbital speed stays high far from the center, signals an extended halo of dark matter. We don't know what it is, but it's the main reason the Milky Way's gravity reaches so far. Easy visuals: plot overlay, speed versus distance curve that stays flat, an invisible halo glow around the disk. The bulge is boxy, peanut-shaped, not a sphere. Peer through the dust in infrared and the central bulge looks X-shaped, the 3D structure you get when a bar buckles and thickens. Many barred spirals share this trait. It's a fossil of the disk's internal evolution, grown from the inside out. Easy visuals: infrared style rendering, central bulge with a soft X silhouette embedded in dust lanes. The disk is warped and a little bent. The outer gas disk doesn't lie flat, it warps upward on one side and downward on the other. Tidal pulls from companions, like the Magellanic Clouds, the dark matter halo's shape, and long-period oscillations all contribute. Easy visuals: edge-on galaxy with subtly upturned and downturned outer edges. Starbirth happens in cold molecular clouds. The brightest nurseries, like the Orion complex, are massive, cold, and dusty. Gravity gathers clumps. Turbulence and magnetic fields thread the gas. Radiation from newborn stars sculpts pillars and bubbles. The Milky Way turns a few solar masses per year of gas into stars on average. Easy visuals: generic pillar of creation style scene. Overlay: cold, dense, dusty, star factory. Spiral arms are traffic jams, not rigid structures. Arms are density waves, regions where material slows slightly and piles up, compressing gas and triggering star formation. Stars and gas enter an arm, light up as new stars form, then drift onward. The pattern rotates with its own speed, the material flows through. Easy visuals: top-down sequence, glowing, wave, moves while dots, stars, drift through it. The center is a central molecular zone, crowded and hot. Within a few thousand light-years of the core, gas densities are high, clouds are turbulent, and massive clusters form, e.g., arches, quintuplet. The environment is extreme compared to the quiet suburbs like ours. Easy visuals: dense, smoky central ring of gas with embedded starburst knots. The Milky Way has Fermi bubbles, giant gamma-ray lobes. Above and below the galactic center loom two colossal, faint lobes seen in high-energy light. They likely mark past outbursts, either brief, powerful feeding episodes of the central black hole or bursts of star formation that drove winds. Easy visuals: side-on galaxy with two translucent balloon-like lobes rising from the core. The halo holds globular clusters, ancient, metal-poor, and tight. Globular clusters are spherical swarms of up to millions of old stars, bound so tightly they've survived since the galaxy's youth. They orbit far from the disk, and their chemistry preserves snapshots of early conditions. Easy visuals: dense starball with a warm core and sparkling edges against black space. The Milky Way is still merging with smaller galaxies. Our galaxy grows by cannibalism. Streams like Sagittarius and Gaia Enceladus are the ghostly remains of dwarfs torn apart. These events heat the disk, puff the halo, and feed the central regions with fresh stars and gas. Easy visuals: simulation-style animation. A small galaxy stretches into a stream as it wraps around an edge-on disk. The Magellanic Clouds are close companions, and messy. The large and small Magellanic Clouds are dwarf galaxies orbiting the Milky Way. They drag a tidal Magellanic stream, a ribbon of gas, across the sky. As they swing by, they may stir our outer disk and feed gas inward, sustaining star formation. Easy visuals: southern sky panorama. Two luminous patches, LMC, SMC, an arc of faint gas, illustrative. We live in a local bubble carved by old supernovae. The sun sits inside a cavity of hot, thin gas, the aftermath of multiple supernova explosions that cleared dust and carved a bubble tens to hundreds of light-years wide. The bubble's walls, host dust clouds and new star formation. Easy visuals. Diagram of a cavity with the sun inside, neighboring denser clouds as a shell. Cosmic rays and magnetic fields thread the galaxy. High-energy particles, cosmic rays, spiral along magnetic field lines that weave through the disk and halo. They influence gas heating, chemistry, and even how clouds collapse. The magnetic field is weak by human standards, but on galactic scales it matters. Easy visuals. Stylized lines arcing across the disk with little moving dots, cosmic rays, sliding along. The sun's address, not just Orion Spur, but a moving target. The solar system drifts relative to nearby gas and stars. It may pass through interstellar clouds that subtly affect the heliosphere's size, cosmic ray flux at Earth, and even, speculatively, upper atmosphere chemistry. Space weather has a galactic component. Easy visuals. Sun icon with a small arrow moving through a patchy medium. Heliosphere bubble breathing in, out. Metallicity maps tell our history. Metals, anything heavier than helium, mark generations of starbirth and death. The inner disk is richer. The outer disk is poorer. The bulge shows complex chemistry from fast early enrichment. These gradients are the fingerprints of how gas flowed and where stars formed over time. Easy visuals. Color-coded metallicity map overlaid on a top-down disk. Warm inner colors, cooler outer hues. Hypervelocity stars are flung from the core. Rare stars move so fast they can escape the Milky Way entirely. One launch mechanism. A close binary wanders near the central black hole. One star gets captured while the other is slingshotted outward at extreme speed. These projectiles map the galaxy's potential like tracer rounds. Easy visuals. A star streaking away from the center with a glowing trail. A faint bow shock in gas. RR Lyrae and other standard candles sketch the skeleton. Ancient variable stars, RR Lyrae, have predictable brightness. Find them and you can measure distances. They reveal the halo's structure, streams, and the bulge's shape. Cepheids map younger structures. Red giants extend reach. Together, they give the Milky Way a 3D backbone. Easy visuals. Dotted halo with pulsing dots marking RR Lyrae, lines connecting them to show streams. The bar's pattern speed shapes what orbits are allowed. Bars rotate. There's a corotation radius where stars orbit at the same angular speed. Inside and outside that radius, different families of orbits dominate, guiding where gas piles up into rings, where arms originate, and where resonances trigger star formation. Easy visuals. Top-down schematic. Bar in the middle. A faint ring at corotation, arrows showing flow. The Milky Way's star formation is modest but steady. We are not a starburst galaxy. The Milky Way's few solar masses per year pace is sustainable because gas trickles in from the halo, satellites, and the cosmic web. Star formation clusters in spiral arms, the central molecular zone, and certain ring-like resonances set by the bar. Easy visuals. Heat map on the disk, brighter along arms and inner ring, dimmer in between. Planets are common, everywhere. Exoplanet surveys suggest most stars host planets. Metal-rich regions tend to grow more giant planets. Smaller rocky planets occur across a wide range of metallicities. The idea of a galactic habitable zone suggests certain radial bands might be friendlier to life, balancing heavy element supply with quieter environments, but nature loves exceptions. Easy visuals. Star field with faint orbit rings around random stars. A few stylized planet silhouettes. The Milky Way and Andromeda are headed for a date. In approximately 4 to 5 billion years, the Milky Way and M31 will begin a long merger dance. Stars won't collide, space is vast, but orbits will be reshuffled. Gas will compress into starbursts. The central black holes may eventually merge. The final product, a massive elliptical or lenticular often nicknamed Milkomeda. Easy visuals. Two spiral galaxies approaching, overlapping, then relaxing into a rounder shape. Time-lapse illustration. We can't take a single, real, exterior photo, and that's okay. All iconic Milky Way pictures are from inside or illustrations built from surveys. Yet we know the galaxy intimately through its kinematics, chemistry, star counts, and gas maps across radio, infrared, optical, and X-ray. The true portrait is multi-wavelength and model-based, and it improves every year. Easy visuals, montage of bands, radio spiral arms, infrared bulge, optical dust lanes, X-ray bubbles. Label, multi-wavelength view. Conclusion, wrap for retention and CTA. Our galaxy is not a postcard. It is a process. A bar channels gas toward the core. Spiral waves compress clouds into new suns. Supernovae carve bubbles that seed the next generation. The halo preserves streams from galaxies we consumed. A dark matter halo holds the whole thing together, and the center hums around a black hole that, in the deep past, likely roared. The Milky Way is still assembling, still forming stars, still interacting with companions that tug its edges into a warp. We live halfway out in a quiet spur, a good place for long-lived chemistry, and we carry our local weather inside a heliosphere while the galaxy's magnetic and dynamical weather plays out on a grander scale. The bigger story reaches forward, too, an eventual merger with Andromeda, a reshaping of orbits, a new, larger home under a different name. If this journey helped you see our home not just as a band of stars across the sky, but as a living machine, part engine, part archive, tap like, subscribe to Solar Infinity 29, and tell me which fact surprised you most. In the next episode, we'll zoom out again, past the local group, along filaments of the cosmic web, and watch how gravity sculpts the large-scale structure that cradles galaxies like ours. Until then, keep looking up. You're inside the Milky Way, and it is very much alive.